Okay.
Yeah, that's fair.
Okay. One minute, please. This is uploading. Okay. Okay. So.
Go on.
Okay. Okay. So you're now a host now.
Okay, cool. So now I can see.
Yeah. You will see
okay, there we go. And then I can make you co-host.
Yeah.
And
be a co-host, and then you can like admin them all to the meeting if you're ready.
Okay, cool.
Okay,
and
cool.
we also have another studio leader which is supposed to joining the meeting soon. He has been waiting for quite a long time because presumably we thought the meeting gonna start 15 minutes prior to the workshop. So, but anyway, I just
I'm so sorry because I don't have because they have reset the password. I'm sorry about this.
So good. Yeah.
Yeah. Okay.
Jeff, can you hear me?
Yes, I can, Sharon.
Oh, cool. Finally, we all got in.
Finally, we're let in. Okay. Let's see.
I'm gonna assign you as co-host as well.
Okay. Cool. Yeah. To everyone listening, we've only just been let in the room, so we're just trying to work out exactly how it's.
Yeah. Apologies to the delay.
Sharon, if you can't assign me as co-host, that's fine. Although it would be better so I can move into breakout rooms.
It's all good. Yeah. Yeah, there you go. You're a co-host now.
Right. Okay. Thank you. Well, why? Here we go. Now you can see me. That's better. Right.
You're using virtual background, and that's it.
Yes. Yes. Well, I had something over my so I completely disappeared. How many participants do we have at the moment?
Right now we have, 6.
Right. Okay. Could everyone turn on their cameras, please, if possible? Thank you, Rob, for having your camera on.
I think Mark is coming.
Yes, Mark should be turning up. And here's Mark.
Hello, Mark. Can you hear us?
I can.
Oh, cool. Oh, it's snowing.
It is at 400 meters.
Jeez.
Flipping freezing. Got 2 puffy jackets on today.
Yeah, that's fair. Need to wear enough to keep warm. We still have people joining in, admit.
Okay, we'll just wait a few minutes for people to have a chance to join, and then we'll commence. Thank you, everyone, for being on time.
Can everyone please turn on their cameras, please, if possible, so we can see your smiling face? People keep joining in. So,
Yeah.
Jeff, probably we can kick off.
Yes, I think so.
Yeah.
Well, let's begin. Sharon, did you want to go or shall I?
Oh, you can go for it.
Okay, great. Look, everyone, thank you for joining our workshop today. We're very pleased that you've taken the time to join us, and we think it should be quite an interesting workshop. We've produced a fairly structured series of design explorations using some code for exploring pedestrian simulation and urban design in Unity. You don't really need to have much background in Unity. We have sent out some things on the MS Teams that will give you a bit of introduction, and then we'll take it from there. And it should be quite a streamlined process and enjoyable. And we look forward very much to going through it with you and having a good outcome at the end of the day. Sharan?
Yeah, and thank you very much for joining this workshop. And as Jeff suggested, we've already prepared the Unity 3D package with the agent-based modeling and the real-time CSG package integrated. And we have already uploaded in the MS Team. So presumably you guys have already tried it in the past 2 days. So hopefully we can work together today and make some interesting stuff by the end of the day, and look forward to collaborate with you guys soon.
One housekeeping thing, if for some reason you haven't installed Unity yet on your machine, could you start the installation process now, and then you'll be ready to work with us a bit later on. Hopefully you have all installed it as we've asked you to on MS Teams. Okay, so we're very privileged to have Professor Mark Burry here to give some opening comments. Professor Burry has been senior architect and lead researcher at the Sagrada Familia Basilica in Barcelona, Spain, and he was awarded the Australian Federation Fellowship in 2005. He's recognised internationally as a thought leader and researcher in the domain of future cities. He joined Swinburne from Melbourne School of Design at the University of Melbourne, where he's Professor of Urban Futures. And he's the founding director of the Smart Cities Research Institute at the Swinburne University of Technology. Mark was recognised in 2018 on the Australia Day Honours List for his achievements in distinguished service in the field of architecture. Okay, Mark, would you like to give some opening comments, please?
Yep, thanks, Jeff and Sharon, for the invitation. And it's very good to meet you all, diversely scattered around the globe, no doubt. COVID's been an interesting time. I'm always careful not to talk about publications that I might have been responsible for, because it always looks like an unashamed attempt to drum up sales. But the one I'm about to refer to costs $1,500 US, so I know you're not going to be going out to buy that, which is the Routledge collection of digital architecture. It's 1,600 pages, 4 volumes. I didn't write all the words, I just wrote a very long introduction. But Routledge invited me to try and set out where digital architecture, what it is and where it comes from. When they invited me, I said I didn't know what digital architecture is, and they said that's why we're inviting you to do it. It is a difficult, because we all know what we think it means, but it's not actually a concrete noun in the way that digital design can be seen as something. It's a process where you design digitally. So as I sort of hurtle towards retirement age, I imagine that, and as an early adopter of computer-aided design, I can see why they might have thought that I was an appropriate choice, because I've sort of seen it all. And I think it's fantastic that you guys have decided to put a day into looking at responsive, informed design for built environments, because I'm convinced that the role of the architect today is to look over the horizon at what the role will be. There's a very interesting piece in The Atlantic It's a long piece talking about the mistakes that might have been made in the US around COVID. And it seeks to take, obviously things have gone very badly, especially badly there, but it seeks to not just put the blame on one person, but to look at the general condition. It makes quite a big point about the 1972 oil shock and the response of architects, as that's who they blame rather than any other professional group, for having made an attempt to build buildings without opening windows so that all the environment is controlled through air conditioning. And we know how successful that is in our current mess. So architects need to think about what they can offer that other professions can't offer, and knee-jerk reactions to energy crises in the early 70s is an example of what not to do. So I'm hoping that the combination of the talent of Jeff and Sharan and your own combined talents and your interest to look beyond what we already know we can do, whether it's BIM or just simply representing ideas, but actually understanding, as your brochure says, the flexible simulation and visualization of urban pedestrian systems and informed design. That's a very specific application, and the idea isn't that you leave the workshop so that you're experts in pedestrian systems in the urban environment, but you see it as a model of a way of thinking and acting as professionals in the future. Because being able to work with data and visualize it in real time in response to what if scenarios is a fantastic opportunity, because it means that in a meeting where you've got people representing all sorts of sectors, not least the end user and the key stakeholders, where you can answer a question. So what would happen if we ... You can start simulating that. So I think if you haven't already been experimenting in games environments, for instance, simulating what ifs, then you're in for an eye-opening experience. And even if you are experienced, the fact that you're working with Jeff and Sharan, I'm certain they will push you to places you haven't been to before. So that's all I wanted to say as a warm-up. I think it's a fantastic opportunity. I'm jealous. That's always my greatest compliment, is when I'm jealous of something that others are about to do that I'm aware of but can't participate in. And I will be, both Sharan and Jeff have promised to show me the results of what you get up to. So welcome and good luck, and look forward to seeing the outcome. Thank you.
Thank you, Mark. Thank you very much for your open remarks. So I think, well, we haven't known each other before this workshop, so I think probably the first stage would be everyone just briefly introduce themselves. I guess me and Jeff haven't properly introduced ourselves as well, so maybe I can start with the first one. My name is Xiaoran, and I'm a researcher and studio leader at the Swinburne University of Technology, and I got my PhD from the University of Melbourne. Prior to that, I got the Master of Architecture from University College London, and my current research interest is about computational modeling, and particularly agent-based modeling and pedestrian simulation. So maybe I hand over to Jeff.
Sure, thank you, Sharan. I am with the Smart Cities Research Institute. I have, as does Sharan, a Master of Architecture. I came from a background in software development originally, and then decided to also switch to architecture. And I've got a very strong interest in simulation and modeling and creating digital tools for such projects. Rob, would you perhaps like to go next?
Yes, so I spent most of my time being an architect in the UK and Australia. So getting involved in prefab and better ways of designing and building. And then 2014, I joined some PhD candidates at University of Sydney, where we focused on prefab stuff mostly. I concentrated on computational design in particular. Completed that 2018, and then a couple of years ago I went to the Welsh School of Architecture, and I've just come back from there to Australia. So I spent some time there with Dr. Wasim Jabi, working on the computational methods in architecture course. And now I'm in transition really. I'll be joining at Uni SA in a couple of weeks' time, and beginning a new start down there. So I've been involved in some of these tools, but not specifically with Unity, but I've enjoyed the past day or so having a go at it. So I look forward to it.
Thank you.
Victor?
Hello, everybody. I'm Victor. Just came to Australia about 1 year. I'm doing my PhD at the USA, University of South Australia. And I'm Brazilian. I did my master in Unicamp with Professor Gabriela Celani in computational design. I was working with space planning in genetic algorithm. And now I'm working with Professor Ningo here. And my interest in how we can use smart technology to improve the urban placemaking process. So it's related to the data-driven approach. And yeah, I'm very happy to be here in this workshop. And that's it.
Thank you.
Thank you, Victor. Then Wei.
Yeah. Can you hear me?
Yep.
Yeah, thank you. Hello everyone. I'm Wei, and I'm currently doing my master's degree at Manchester School of Architecture in UK, and my major in urban design, and currently thinking about the future workspace and how the people living in their workspace. And it is my honor to be here and attend this workshop. Thank you.
Thank you, Wei. And then Li Bin. Sorry, I can't hear you. Maybe just put the microphone a little bit closer. So.
Can you hear me now?
Yep,
Yes.
sure.
Okay, sorry. I'm in a library, so I should just introduce a little about myself. From China, and I'm a PhD at South China University of Technology now, and I'm learning at the Victoria University of Wellington as a visiting scholar, and my major is architecture design. My research is about healthy building based on the simulation analysis. So it's my honor to be here to study with you. Thank you.
Thank you, Bin.
Well, next is GZX.
Presumably there's an abbreviation.
Yes.
Initials.
Can you hear me?
Yes.
Hello, everyone. I'm Gu Zuoxing. You can call me Gu from Tongji University, and I do the PhD candidate here, and I use some simulator to do the simulate about the pedestrian and to utilize this to research the urban program, the waterfront urban program. But I'm not so familiar with the Unity system, because my Unity version, some program here, I try to use it. So I want to learn some new information, and especially you all mentioned the unit simulation will be more precise and more funny and more AI intelligent. So I want to know more about it. So that's why I came here and hope to see more information. Thank you.
Thank you.
Thank you. You can only see the profile picture of Xiaoting.
Hi everyone.
Hello. Hi there.
Yeah, I'm Xiaoting, and I'm from Tsinghua University, China. Now I'm a PhD with the Academy of Art and Design. My major is industrial design, and I'm very interested in artificial intelligence and digital technologies. And industrial design has much to do with algorithm, economics. So I think Unity simulation can help help me with that simulation, economic simulation. Uh, so I'm eager to learn some new techniques. Follow you all. Thank you.
Thank you.
Thank you, Xiaoting.
Hi guys, I hope everyone is well. I'm Ripple. I'm an architect in India, also an entrepreneur. I graduated from ADRL in 2018, and since then I have been working in India on an entrepreneur project also, which was my research, and I'm trying to develop it as a real-time project here in India. And this is a technology that I'm developing on co-living and co-working, which is like directly related to the project that I was working on while I was in London. I worked with Shajib Bhushan, and my project was more driven towards data design, and we were investigating different ways of mass customization and mass production in the housing sector, and trying to develop various methods for community housing as well as uh, prefab architecture. So this has been my part since past 2 years that I have been working on this project here in India and trying to develop this technology. And soon we would be out with some part of it in the market as soon as some things start to resume back in India. Apart from that, I have been working with some colleges here in Mumbai, where I have been involved academically with students and trying to work further on the research that I have been trying to develop into robotic fabrication. So that has been my time here so far, and I hope to engage with everyone soon in this whole workshop time. So thanks for that.
Thank you.
Zelda?
Hi everyone. I'm Selda Purali from Tabriz Art University in Iran. My major is technology and architecture, and I love the interaction between urban studies and technology and digital architecture, also bionic architecture, and I'm so interested in joining this workshop. Thank you.
Thank you.
Thank you, Sada.
And finally, Shahan. Yeah.
Hi everyone, I'm Xiaohan Xu, a master's student in the Department of Architecture at UCL, and a major in urban design. And my current research and project is about data-driven urban analysis and generative design responding to environment. I'm really interested in this workshop because I think pedestrian simulation and feedback in real time is really important for responsive urban design. So really glad to meet you and study with you guys.
Thank you. Okay, well, that completes the introduction, so it's very good to meet you all. Sharan, did you want to commence with the lecture or do the overview of the workshop structure first?
Yeah, maybe we can do the overview later on. I can start the lecture first when everyone is quite concentrated. Okay, just bear with me a sec. I'm gonna open up my PowerPoint to give you guys a very short lecture covering some basic idea and key concept of pedestrian modeling, agent-based modeling, and the walkability. There we go. Can you see the screen? Because I'm not having door screen operating right now, so I need to find a place to. Can I minimize the window? Okay, it's only you, so it should be fine.
Yep.
There we go. And thank you everyone to joining our workshop today. And before we jump into the super technical and sophisticated Unity-based pedestrian modeling, I think it will be better for us to have a brief overview about several key concepts and ideas for walkability, agent-based modeling, and pedestrian simulation. So the first thing I would like to talk about is the walk and walkability. So we're about to doing the pedestrian simulation in Unity 3D. You might ask, why bother? Why bother using it? Why bother, simulate pedestrian behavior for proposing a better urban design agenda or proposal? So what I'm trying to say is that even though as a human being we have already invented a lot of advanced and sophisticated public transportation system like tram, trains, and also private vehicles, of course, our commute within last 1 kilometer is still very heavily depends on foot. So increasing the walking, let's say, enhancing the walkability and increasing the walking experience within contemporary urban scenario is still a very important topic for most of the architects and the urban designer. So here comes a key concept of walkability. Well, there's no specific definition about what walkability is, but in general, we can say walkability is an evaluation or measurement that describes how a natural or built environment is friendly to walking. So why it is important, according to the latest research, we can say enhancing precinct walkability could increase our health, reduce the energy consumption, increase our mental happiness, boosting local economy, and of course, boosting the social capital as well. And how do we actually measuring the walkability? Well, one of the most commonly used approach would be walkability through walkability index. So it's actually an approach that transforms walkability into quantitative matrices or indices. And in the past 20 years, many research have devoted into this area, like Billy Giles-Coty, Donovan, and also Ewan and Frank, who were all based in United States. And in the past 10 years, many researchers tend to migrate this kind of design approach and strategy into some digital platforms as well. Right now, we can find out there are many readily available tools online. Say, for instance, like WalkScore is a web-based walking experience evaluation tool, which provides a heat map to describe how a place is friendly to walking. And also we have Oren walkability tool as well. And if you are familiar with the JS platform, you can find out there are many plugins available for measuring walkability as well. So we can say walkability index is very useful and informative to describe for architects and urban designers, and it could describe how a place is friendly to walking in a static way. But we all know that pedestrian behavior is rather a dynamic, behavior. We're not only concerning the static built environment, but also we need to understand the the pedestrian flow, the interaction between the individual pedestrian and also the overall crowd behaviors. So for Forge, or having a better understanding about these kind of dynamic behavior, we need to introduce a dynamic modeling strategy and approach. And amongst most of the current strategies and technologies, we can say agent-based modeling is one of the most visible and efficient toolbox to simulating pedestrian behaviors. The definition of ABM is, this one is pretty long, but I'm still going to read it out. It is actually a computational model approach for simulating the actions and interactions between individual and autonomous agents, with a perspective to evaluating their effects on the system as a whole. So if you are familiar with movie industry and the game industry, you have probably already found out the ABM implementations in those industries. Say, for instance, in the epic movie, The Lord of Rain, in the third episode of The Return of King, for the last scene, they have used a lot of agent-based modeling techniques to simulate the coverage. And same strategy applies to many strategic games as well, like Total War 3 Kingdoms. They use agent-based modeling to simulate both individual and collective soldier behaviors. And there are, So we can probably flip through some basic short history of ABM. We need to date it back to like 80 years ago. In 1940s, the godfather of modern computer, von Neumann, crystallized the idea of cellular automata and the state machine. I think CA, or cellular automata, can be considered as the a simplified version of agent-based modeling. And in 1970s, we have Conroy's Game of Life, and eventually in 1980s, we have Reynolds, and also his flocking agents model available. For those who are not familiar with the flocking agents modeling, it's basically a force-driven based agent-based system, which used to mimic the flocking behavior of the birds. There you can, because of the time limitation, I don't really have time to expand this part, but if you're interested in this area, you can probably just type it in Wikipedia, and it's pretty straightforward. Yeah, for the agent-based modeling implementation, there are many ways of using it. We can use ABM for flow modeling and simulation. Say we can simulate some emergency scenarios like fire escapes or under terroristic attacks. And we can do energy system modeling, and we can use ABM to simulate stock to predict the stock market, and use it for property modeling and analysis as well. So there's so many ways of using agent-based modeling in contemporary society. And of course, for architectural and urban design, we have already, there are many precedents of using ABM as well. So in 2001, two professors, Turner and Penn from University College London, have crystallized their VGA-based visual graphic analysis-based agent-based modeling system. And it has been integrated with their space syntax model. And in 2013, a researcher called Gideon Ashwandhan, or in ETH, has done a agent-based modeling simulation, which aims to investigate the correlation between arrow exposure in Singapore and the pedestrian behavior. And in 2016, Marcus White, a professor in University of Melbourne, and Jeff Kim, which we have him here, have developed a pedestrian ABM accessibility evaluation tool called PetCatch. And it's already readily available online. And if you guys are interested in this kind of accessibility evaluation tool, you can feel free to use it after this workshop. So you might ask, well, we already have these toolboxes available. Why bother reinventing the wheel, or why bother create a new agent-based modeling system in Unity? Well, I think these analysis or the critical review of existing toolboxes could tell the story. Most of the current agent-based pedestrian simulation tools are either too expensive or too hard to use, or let's say have a fairly steep learning curve. So that's why in this workshop, we are trying to introduce a new agent-based pedestrian modeling tool embedded with the Unity platform, which is supposed to be easy to use and open to the public. So this is what we have done before using the Unity ABM system. It's a fairly simple test to investigate the sidewalk capability for pedestrians. And of course, we can also simulate pedestrian behavior in a larger scope. This is for a precinct scale pedestrian simulation. Okay, so let's jump into a more technical area. So when we're talking about ABM simulation, there are basically two commonly used techniques. One is called force-driven, and another one is called graph-based. So the first one, force-driven. Let me use the classic flocking model as an example. For some reason, yeah, it's moving right now. I'm using the classic flocking agent-based modeling system as a reference here. In the force-driven ABM system, each single agent is steered or navigated by different kind of forces. And for each single agent, at each frame of the simulation, it would do the force, say, combination. I'm going to take, say, for instance, in the flocking model, we have three different forces, which are separation, alignment, and cohesion. So in the system, each single agent needs to consider the force combination and also the interactions between other agents as well. And we have another way of creating the ABM navigation system, which is graph-based. In this system, unlike the force-driven system, all the routes or the paths are pre-calculated. So basically, we're going to divide a surface into a graph-based nodes and calculate the shortest path for each agent computationally. So if you have played some RPG game, you might be wondering, when you control the main character and click somewhere on your screen, how could the computer know where it goes and what is the shortest path? This is actually based on the graph-based pathfinding system. So because we will be using Unity 3D for this workshop. So here I'm taking the nav mesh for as an example. So the navigation mesh is literally a mesh, and as its major vertices are used to define large areas of space by deconstructing a whole polysurface into a group of smaller meshes. And this process is often done by triangulation. And now we have the divided meshes. And after that, the system will generate a nav mesh grid, which is a structure which describes the workable nodes of the game world and allows to find paths from one workable location to another. So if you can look at the GIF image on the right-hand side, you can find the blue areas are nav mesh, and those black lines and nodes represent the nav mesh grid. And the agents, those small gray cylinders, are moving across the nav mesh following the optimal path generated by the system. So you may ask, how does the optimal path generated? So actually, we have two different path-finding algorithms that are commonly used for today's graph-based system, which are A* and Dijkstra. Well, the Dijkstra algorithm has been considered as the oldest and the most classic algorithm for path finding, and it searches every possible path, but it does not need to, to have the location of endpoint, and it guarantees you'll find the optimal path, but the whole process may take a quite long time. And on the other hand, the A* is actually much faster than Dijkstra algorithm, but sometimes it will not return you with the so-called shortest path. Okay, so before I hand over to Jeff, I think it would be good to make a short introduction, but also a summary for the nav mesh system. So from this image, you can see that nav mesh actually consists of four important paths, which are nav mesh obstacle, nav mesh agents, off mesh link, and the nav mesh surface. So the navigation meshes are created automatically from your scene geometry, and the obstacle, not necessarily to be dynamic, allows to alter the navigation of the characters, and your agents could not pass through it apparently. And another mechanism is called off-mesh link. I don't think we'll be using this one in this workshop. So if you have any questions regarding the off-mesh link, probably we can discuss about it later or maybe after the workshop. So maybe I can hand over to Jeff for a more hands-on tutorial. Or do we have any questions? Sorry, because of the time limitation, I have to go through the slides really fast. Do you guys have any questions or any thoughts?
Okay. Well, look, there'll be a chance to ask any questions after I present as well. So I'll get on with what I will be showing.
Okay, sure.
So I'll be presenting an overview of the nav mesh in Unity, just to extend a little bit what Xiaoran has talked about in practical terms. And I'll be showing as well our custom agent system scripts that we've set up to make it quite easy to do some work in Unity today. So I'll share my screen. Where's that going? Oh, down the bottom. Okay. Okay, you should all be able to see a Unity interface. Can I get up the... Oh, right, okay. I can't see you at the moment for some reason. I can only see the participant list, so I'll assume you're all nodding and saying you can see the Unity interface. Okay, so what I've shared is a picture of the Unity interface. This is the environment we'll be working with today. Now, I believe some of you have used it moderately extensively already, and you should all have at least a basic overview from the material we've shared on MS Teams. But I'll be going over the essential elements that you'll need to work with today. So to begin with, I'll just cover some basic parts of the Unity interface. Now, over here where my mouse is the tree of elements that are within the scene. This is the scene here. Everything within this is what is called a game object. I'll be going into the details of what those game objects are, and we can turn things on and off. So here is a sample ground plane, and it's possible to turn it off so it's no longer active in the scene, or turn it on. And I'm doing that over in the right in the inspector. So what happens when you select something over on the left, a game object, you then get properties in the inspector on the right, which shows all the fundamental qualities of that game object and also what components are attached to it. So some essential qualities. So if on the left, I select one particular ground plane, which you can now see selected in the center, we then get all the components attached to that ground plane, and we can see them in the inspector. As I said, some are essential, such as the transform, which gives the position, rotation, and scale. And we can easily adjust that. For example, here I'm changing the position in the y-axis, and you can see it's going up and down in the scene in the middle. Also attached to this ground plane is a plane component, which is saying what the game object is, in this case, a plane. There's also the renderer component, which is telling Unity how it should be displayed. And there's also a collider, which is what gives the ground object a physical presence, or the game object a physical presence within the game. So this collider means that it's a plane within the physics system that can interact with other objects within the physics system. And so agents, in our case, will be able to walk on it. Now, there are other optional components. If I go down here on the right and add component, you can see a whole list of components that we can add, and these all pop out to other parts. Now, the primary component we'll be dealing with today is a script. However, I won't add a script now. I'll be going into the details of scripts at quite a basic level in just a moment. So this is the scene view in the center here. You can see on the tab here, it says scene. And this is what we use for designing the environment and doing our basic setup. But there's also what's called the game view. And if we go up here to the play button and run, it just takes a moment to load. We can now enter the game view. And so in effect, we have a basic game that does absolutely nothing except show a ground plane. And one thing we'll be doing today is actually making that a bit more engaging and useful. Another component within the interface is down here, which is the project. And that shows how the files and assets that are part of the project are organized. For example, if we go to the assets folder, and down here, there are, for example, a whole lot of little trees that can be dragged into the environment. Okay, we can also place objects directly through the scene tree, as well as dragging them as a pre-made asset. So if we go up into here, in our scene tree of game objects, we can see we have intro environment. So I'll do some work within the intro environment, to show you some examples of what we're doing today and get you going. So the first thing I'll do is I'm creating an empty game object, which I'm essentially going to use as a folder for some other game objects I'm creating. And I'm going up here to the inspector, and I've changed the name to live. The next thing I want to do is, so we can do a test of a little agent, is I want to create a cube. So I just right-clicked on the live folder, 3D object cube, and that has now created a cube within it. And I'm going to go to the inspector and rename that to beeline agent, which we'll do a little test of a script with. Now we can now move that cube around just using the controls when we click on it. And there's also other controls up here in the top left, such as rotate. So clicking on rotate, I can now change the rotation, and you can see over in the inspector on the right that the rotation in the y-axis is also changing. Okay, I'll now introduce some very simple scripting within Unity, and this is for a few reasons. One is to introduce the concept of creating relationships between Unity objects to actually do something within our game. The other is to show how to interact with script parameters, and it's also to show why the nav mesh for pedestrian simulation is a good quick alternative to doing it all ourselves. So I'm going to use the cube we just created as the game object, and I'm going to use a script that I created earlier to actually do something to the game object. So down in our projects, in the scene, in the call scene, we have a script called move to goal. And over on the right, we can see the actual script contents itself. The script is quite short. The fine details of the script aren't really important, except there are two things that we should take note of. One is that the script has some parameters within it. This is a goal and also a speed as a number. And we'll be able to access those parameters later when we add this script to a game object. The other is that the script actually does something, and this function here, update, is called once per frame. So every frame, this script has an opportunity to do something. And all this script is doing is finding the direction to the provided goal, moving towards the goal at the desired speed, and then stopping if the agent is very close to the goal. And that level of detail is the entire conceptual material you need to understand for using scripts today, because we've done the work before you for you already. Okay, so if we go to our cube that we created earlier and named beeline agent, and then take the script we were just looking at, we can drag it over, and we've now attached it to the cube as a new component. And we were looking at these two parameters before in the script, goal and speed, and we can now see them in the inspector. And we can actually start to assign and play around with these parameters to change how this script is going to work. So you can see the first thing it needs is a goal, and at the moment there's nothing attached. So let's go to our live game object, and we'll create a sphere. We'll go over to the inspector for the sphere, and we'll change the name to goal. And let's just move it a bit further away from our agent. We go back to our agent, and here's the goal parameter, which is still empty. We select the goal and drag it across. Okay, now our script should be ready to go. And when we run the game, this time we'll actually see something happen. Okay, so we can see that the cube agent is now moving towards the the goal. Okay, now when this is happening, we can actually go up here and pause the game, and that takes us back to the scene view. And we can actually move elements around if we wish. For example, we can move the agent much further away and then restart again. Now, look, it's important to keep in mind that any changes made when a game is paused to either the game objects over here or parameters for a game object script won't persist after you stop the game. They're just for testing and temporary. The other thing we can do is we can go here and change the speed live. So we can slow it right down or we can speed it right up. Now, the final thing is you'll notice that I'm flying around the map. If you've ever played a first-person shooter game, you'd be familiar with the controls. I'm just using the mouse to look, the WASD keys to move around, and the Shift key to move faster. And then to escape that mode, I just hit escape, and that allows me to get my mouse back to interact with the Unity interface. Okay, so the script that we've just shown is clearly a very naive approach to walkability, as walkable areas and voids such as this are completely ignored. Now, to create a robust agent script with realistic behavior would quickly become quite complex. And so, of course, there needs to be a better way. The agent needs some information about the environment so it can properly navigate. And for this, we'll use Unity's inbuilt nav mesh. Now, Xiaoran has shown the essential concepts behind the nav mesh, so I won't reiterate those here. And for our work today, the nav mesh provides a convenient way of generating the walkability information we need and we can build on, and saves us writing complex code for these pedestrian simulations. So creating a nav mesh is very simple. Sorry, I've zoomed out entirely too far. And it now doesn't want to. There we go. Okay, creating a nav mesh is very simple. There's two core operations. One is selecting the objects that need to be included in the nav mesh, and the other one is actually telling Unity to create the nav mesh that will then be saved and used for when running the scene. So to select the objects that we want to use, I'm just going over to the scene view, and I'm selecting the parent ground object under which are all the plane objects. I then go over to navigation, make sure that we're looking at the bake part here, and I just click bake. Okay, and that creates the nav mesh. Now, if when you get to doing this, you can't see the nav mesh, you probably just need to go up here above the scene and click gizmos. And that allows you to then see the nav mesh. Okay, so just as a simple example of how this then allows us to use scripting to create an agent, I will turn off the beeline agent we were just using. And under the live folder, I will create a cylinder. And I'll move that a bit. It's going to be a bit slow. I'll move it to there. And there's another short script that we'll then attach. Now, this script is very similar to the previous script in that it takes a goal. The difference this time is that the object this is attached to will be treated as a nav mesh agent. And so that nav mesh agent and the nav mesh will do all the work. So let's see how that works. We'll take the cylinder, which I will rename now to basic agent. And drag the basic agent script over. Now it also needs the gold set, just as the other one. And it needs one other thing attached. So as this is now using the NavMesh agent, the game object, which is here, the basic agent, NavMesh, as it's using the NavMesh, it needs a NavMesh agent attached. And now that that is attached, we can actually just run it and it will all work. So this time we can see that the agent we've created is actually doing something sensible. It's respecting where the walkable areas are and respecting where the voids are. Now, there are a few complexities for creating nav meshes, such as how suitable the ground is for walking. You can say whether the ground is good to walk on or not so good, such as a road. Sharan will cover some aspects of those in a section he will do next. Okay, so I'll introduce the agent system custom scripts that we've created. So rather than you having to write code and assign goals to every agent by hand, we've created custom scripts that will do it all for you. So my introduction you've just seen to the Unity interface gives you all the skills you'll need to use it. And all you basically need to do is create game objects as start and end points and adjust parameters on a few scripts. Now, I believe on MS Teams, you were provided on Sunday with a PDF guide of our agent system. So I'll only give a brief overview here of the workflow steps, and you'll be able to refer back to that PDF guide, which is only about 6 pages and quite concise. The first thing I'll do is I will turn off our previous work under the live folder. And under intro environment, I'll go to agent system and turn on our agent system. Oh, we're still running. Okay, so now I've turned on the agent system. No, well, now I've turned on the agent system. Underneath, there are 3 key game objects: agent spawner, agents, and sensors. And here and elsewhere, we've used a consistent naming scheme to give you a bit of a hint about what can be done with things. The plus next to agent spawner means that you'll be able to add game objects under it. The tick means that there is a script attached and you can change parameters within that script. The don't touch is pretty self-explanatory. That's internal stuff, and if you play around with it, then something might break and it might stop working. Okay, so I'll show you the agent spawner first. The agent spawner node or game object allows you to decide where from and where to agents will travel. And it only has a few basic components. Now, the first part is anything that is any game object that is added under agent spawner will become a spawn point. If we select any one of these objects that are spawn points, we can see that there's an optional agent spawn node script attached. And that allows you to say whether a spawn point is a start point, an end point, or both. Now, the easiest way to make sure that a new spawn point you create has the agent spawn node attached is just to right click and say duplicate. And then here's cube 3 we just created. We can say see the agent spawn node is attached. If, for example, we just did it another way, such as adding a sphere under it, we can see the newly created sphere doesn't have that script attached. I'll just delete those 2. The script parameters for the agent spawner script, which is attached to the agent spawner game object, are very straightforward. You can set the minimum speed and maximum speed for a newly spawned agent. There's 2 types of model, basic and animated. The basic is just a peg. The animated is a little running person. And you can also set the spawn rate and maximum number of agent alive at any time. So the agent controller script is attached to the agent object. And this agent controller script determines what measurements agents will make of their surroundings and display when the game is run. And we've provided a number of display modes in these parameters, and I'll demonstrate those when we run the scene. Finally, there are optional sensors. And the locations for the sensors are set in the same way as we do for the agent spawner. It's just child objects underneath the main one, and any child object will then have a sensor in that location. There is one difference in that these child objects have no script attached, so it doesn't really matter how you create them. We've just used spheres for consistency so we can visually see where they are within the environment. The sensor controller script has two parameters. One is range, which is the distance to which it will sense, and the other is the moving average window, the number of seconds over which the count of passing pedestrians will be smoothed. Okay, so the next thing to do is to actually run this. So I will do that now, and you'll be able to see what we've just spoken about in action. So you can see that these are the spawn points here. You can see the agents are created automatically from those spawn points, and you can see that there are sensors. Now, to look at the different modes that we've made available, the first mode is just standard. The agents do nothing except just move back and forth. They don't actually measure anything. The next is distance. And that is basically a simple metric of how far agents have traveled. And once they travel past a certain limit, they'll start to change color towards what we say is the bad color, red. And that is fully configurable. The next mode is speed mode. And this shows how efficiently agents are moving in the crowd, and congestion can cause agents to slow down. And so you can set what the acceptable reduction is. So here, for example, you can see that people are becoming quite congested. They're bumping into each other. We could emphasize that by setting the acceptable reduction to 0, or we could make it less sensitive by saying the acceptable reduction is 50% of speed, and then we don't actually see much of the congestion being displayed at all. The next mode is directness. And what this one does is it compares a beeline distance between the start and end points for each agent compared to the actual distance they've traveled. And you can, similarly to the acceptable reduction for the speed mode, there's an acceptable increase in distance. So this is set at 100% by default. You can make it stricter and say that people should be moving sort of directly as the most efficient route, or we can make it a bit more lenient. And as I increase it, you can see that all the agents are becoming green. Okay, the second last mode is proximity mode. This is somewhat similar to the speed mode in that it shows a measure of how crowded the environment is becoming. And this embodies a illustrative measurement of how comfortable people are feeling. You know, is their personal space being encroached on. So here you can see that everyone is starting to become feeling a bit crowded, and there's a personal space distance of set to 3 meters initially. And there's also this proximity interval. That's how often per second, or the time in seconds between calculating this. And that's just for anyone with slower computers who want to make this a bit less intensive, because it's doing a bit of computational work behind the scenes. Now, the final mode is the solar mode. I will turn on some buildings, or one building. Okay, so I've added the building, and you can see that it's casting shadow. Now, we have provided a way of changing the sun condition. There is one sun up here in the top left provided in the scene. And we have attached to it an aligned sun script. And this allows you to set the latitude and longitude, and then do test for the summer and winter solstices 3 times of day, 9 a.m., 12 p.m., 3 p.m. So I can go up to this little 3-dot menu up here, and there are some pre-configured locations. So because I'm in Melbourne, I've set it to Melbourne. So June 21st, 9 a.m., 12 p.m., 3 p.m. Now, if we go back to our agent controller script, we can now test the solar metric, and we get a bug. So that is not one that has occurred before. What I'll do is I'll just simply restart. Okay, there we go. So I will now set solar mode. Oh dear. This is the problem with showing things live, is everything that worked previously suddenly stops working. No, that is fatal. Look, I'm going to have to investigate exactly why that is happening. That was not happening previously, and I don't want to open up Visual Studio in the middle of a lecture. I will just give you a verbal explanation of what solar mode does, and then I'll fix it up and make sure that you'll be able to use it. So if we go to the agent controller, solar mode has 3 settings, delta sun and delta shade and solar interval. Solar interval is just making the calculation less frequent for slower computers. Now the delta sun and delta shade help adjust what the agent's experience of solar amenity is as they move through the environment. So an agent that would be moving here in shadow would recognize it is in shadow, and it has an experiential solar amenity score of 0 to 100. So when it is in shade, it loses 20 points per second. When it moves to sun, it gains 20 points per second. And these two figures are adjustable, so you can lengthen or shorten how they remember solar amenity and change the relative importance of them. And what this allows you to do is to make a simple measure of the solar amenity in the environment as it's experienced by people moving throughout the environment. Another thing that happens is that as an agent moves into shadow, appearing on the obstructing object is a little marker showing the exact point that is causing that shadow. Okay, that pretty much concludes what I was going to say there. Next, Xiaoran, I think, will introduce building modeling in Unity with constructive solid geometry and how you can undertake some design iterations. I'll stop sharing my screen. Before I hand over to him, are there any questions? I know that will seem like quite a lot of complex things. I needed to provide quite a lot of detail there, but the essential workflow of using what we provided is quite straightforward, and we'll be always on hand to answer any questions about how to do anything. And it will become clearer as well as Xiaoran shows some of the work in the next stage.
Sorry, I just have questions. Yeah.
Yes.
So I just saw the files and documents in our Teams group, and does you just show some buildings layers and some layers of the surfaces? Does these things also included in that file?
Yes, there's a, if I understand your question properly, there's a Unity project shared by Xiaoran that has the exact environment that you saw on my screen. So it has everything that you need.
Oh, okay, cause I just trying to import that document in my computer, and I just found it's just 2 layers of.
Oh, right. Okay.
Oh, you haven't opened up the scene, right?
Yes. What you need to do is you'll need to go down to the project in the bottom left, click on Assets, Scenes. Under that, you'll see something labeled Core Scenes with the Unity logo, not the folder, but Core Scenes. Double click on that, it will open the scene for you. And then you'll have access to it.
And I have a problem with this script here because for some reason I cannot add the script to the queue. It's just saying that the associated script cannot load. Please fix any compile error. And I saw that the errors are in the plugins, real-time CSG, API, components, runtime. I think that's a plugin that I have a problem to upload.
Yeah, real-time CSG is the plugin that we're using for geometry modeling. If I understand what you're saying that you were attempting to make a simple cube as an agent and attach one of the scripts that I, the basic scripts I tried. It's extremely odd that real-time CSG would be causing any interference with those scripts under normal operation. Perhaps if you could copy the error message and send it to me in the chat privately, I could have a look at it.
Okay, okay.
But those scripts were only to illustrate basic concepts as foundation for what we're providing for you. You shouldn't need to use them yourself in this workshop.
Okay, thank you.
Any other questions, or shall Xiaoran proceed? Okay.
All good.
Xiaoran.
Yeah, it is one thing. I think, well, for the solar amenities problem, I think probably you can switch back to the normal agents instead of using Avatar and see whether it works or not.
Well, yes.
It might be the Avatar that's causing the problem.
I think
animated.
I actually, Sharon, I suspect.
Yeah, because I'm not familiar with the Unity. I'm just trying to debug the problem. But
we completely understand, Victor, that we're presenting a lot to you and asking a lot. If you're feeling it like it's a lot, don't think there's any problem with you. It's because we are asking a lot. Okay, but we're going to guide you through it, and then we'll have the rest of the afternoon to do some exploration.
Yeah, we still have like 4 to 4 hours left, so we can still give you some hands-on help. And yep, so maybe Jeff, you can switch it back to the normal pack and see whether solar amenity works or not, and then I can proceed to the.
I think you're right, Sharan. I've made a mistake.
Okay then.
Let me just check. No, there's something definitely wrong. Okay,
right.
look, if you proceed, Sharan, and I'll...
Yeah,
I'll
okay then. So, yeah, meanwhile, you can look into the solar manatee stuff. Now I'm going to share my screen. Okay, there we go. Just want to add some simple, comments and to let you know that actually there are actually some shortcuts in Unity. So it's pretty similar to, well, it's like a combination of a SketchUp and Rhino. If you click on your middle mouse button, you'll be able to move the scene, and the right click button, you'll be able to rotate the camera, and scroll your middle button, you'll be able to zoom in and out. Those are the simple command. I reckon you guys have already tried that before, but I think it's also worth mentioning that. So you can, it's easier for you guys to control the user interface. Okay, so what I'm going to covering is the real-time CSG, which is a plugin, or we call it asset for Unity 3D for real-time modeling. Because as we all know, Unity 3D is a game engine, and it's not designed for any sophisticated model procedure. We can actually do it in Rhino or SketchUp or 3ds Max, but it will be pretty hard to model anything complicated in Unity without the help of plugin. So before introducing the real-time CSG, I think I should also mention how you create simple geometries in Unity as well. You would need to go to the game object, and you can find there are two panels, which is called 3D object and 2D object. And in the 3D object, you'll be able to create those simple geometries like cube, sphere, capsule, cylinders, plane, and quad. That's the basic geometries that you'll be able to generate directly in Unity platform. But with the help of real-time CSG, we'll be able to create something far more complicated and more interesting. So if you can jump back to your Unity 3D interface, I'm going to close the intro environment first and open up the environment called working environment. You'll be able to see a empty plane down there. There are some low polygon, the spawning point, which are those black cubes, and we need to close the sensors as well. Okay. So if we're running the working environment scene, we'll see the agent is actually traverse between those spawning points, as what Jeff has already introduced previously. What we're going to do is create some barriers or obstacles between those spawning points, say using real-time CSG. You can find the real-time CSG interface down there. There are 5 options, which are place, that allows you to move your objects around, and the generate, which allows you to create a new object, and the edit, that allows you to to change the vertex, and also drag the edge or change the surface materials. And the clip, we're not going to use that for this workshop. And the surface, you'll be able to change the materials, change the UV settings, and rescale the surface as well. So how can we create a new geometry in Unity? through real-time CSG. What you need to do is to click on the generate button, and you'll be able to see several options down there under the generate panel. We have free draw, we have box, sphere, cylinder, and linear stairs. Here, I'm going to create a box. So down there, you'll be able to find a small yellow dot, which is actually snapped to the grid of the Unity coordinate system. And click on that, you'll be able to create the first node or the vertex of your geometry. Pretty similar to any other modeling software like Rhino and Grasshopper. And then you create a second one. Oh, sorry. Create the first one, and then you create the another node, which is a diagonal to the first vertex. And then you will have the let's say the ground surface. And the next step, you need to extrude the surface, or you can type the height down the generate panel. So here, what I'm doing is to drag the arrow, the green one, and extrude the surface. Okay, and then we'll have a box generated in the Unity interface. And we're also able to move the object by switch back to the place mode, up and down. You can move it vertically and horizontally. Okay. So we're also able to change the existing geometries by switch back to the edit mode. So there are several options. We can select the vertex, edge, and the surface. So for instance, right now I'm clicking on the vertex, and if I click on the box and select one of the vertex, we'll be able to drag that vertex. Right, and create a new morphology. And we can change the edge as well. We need to deactivate the vertex mode and click on the edge. And we'll be able to change select the edge and change the created morphology as well, both horizontally and vertically. It's super easy to use. And the surface as well. Right, if you are familiar with SketchUp, I think it will only take like 5 minutes for you to getting used to real-time CSG. And if you are not satisfied with the surface materials, okay, no problem. You can switch back to the surface mode, and you can see there's a small little dot besides the existing material. We're using the wall material right now, and if you click on that button, it opens up a material library, and you could change to something else, change the material to something else. Say, let's use the default diffused material. Oops, sorry, I need to click on that one. Yeah. And then we'll be able to change the material of that surface. Okay. And just for your convenience, I personally would like to drag the real-time CSG panel down to the right-hand side. So you can basically drag that one here. So it wouldn't occupy the the interactive interface, the scene interface down here. Okay, so what I'm going to show you next is to create, let me just create other obstacles as well. So we can create some, let's say, free draw, which allows you to generate more complicated geometries. So what we are going to do is to create something similar to footprint. And oops. Okay. And give it a height to 20. And click on create. Okay. And then you'll be able to get a more complicated geometry in your Unity system. And another thing needs to be mentioned is that all the geometry created by real-time CSG will be stored in the model, let's say, folder on your left-hand side under the hierarchy panel. So if you want to drag that folder into one of your existing working environments, what you need to do, just click on the model and drag that one under your working environment, and that's it. And I think Jeff have already explained to you how to create a basic navigation map. Here, what am I going to do is to tell you how to generate the obstacles for the map mesh. So here in this map, this map mesh is what has been generated previously. And what we need to do is to update the map mesh. So what you need to do is to click on the navigation panel and click on bake. And we'll see that all the geometries that generated by real-time CSG will be automatically recognized by the navigation map system. And those objects will be considered as obstacle. So if we click on the running button right now, you'll see the agents actually recognize those obstacles and trying to avoid being collided with those geometries. Okay, so we'll be able to use these techniques to generate your own urban morphologies, street forms, to simulate certain, urban design agenda or urban design proposal. It's fairly straightforward, and it is actually much faster than you create something in Rhino or SketchUp or 3ds Max and re-import it into Unity 3D. And that's for the basic intro for the real-time CSG system. What I'm missing? Yeah, there's another useful stuff. Is called subtraction. So if you're trying to subtract or you want to do something similar to the Boolean process in Rhino, what you need to do is to create a new geometry. So here I'm going to create a sphere. And I can change the attributes of this sphere into subtraction. And it actually digs a hole to the existing geometry. right? It's actually doing the Boolean process. And if we rebake the navigation map again, you will find this area has been recalculated. And this Boolean area is recognized by the NavMesh system automatically. Okay, it's a very useful command. And let's jump back to the case study. So let me see. Based on the agent-based modeling system we've developed and the real-time CSG modeling plugin, we have created a case study environment, which is based on the Superblock urban fabric in Barcelona. So if you are familiar with the Barcelona city fabric, you'll probably find it's pretty interesting. What you need to do is to create a plan using the component, the game object, sorry, the one that I've mentioned before, and create a plan. In this case study, the size of the plan is 300 meter times 300 meter. So you'll be able to rescale it and transform in this area down the inspector. So if you click on, sorry. If you click on the plan, so you can actually rescale the plan with 30 in x-axis and z 30 in z-axis. The basic size of the plan is 10 meters times 10 meters. So if we rescale it with 30, then it's a 300 meter times 300 meter. And I would recommend you to download a satellite map using Google Map or Google Earth and attach it to the plan as material. So that will be easier for you to, tracing the boundary of the existing urban fabric. And if I turn on the model, we'll be able to find those brushes that's modeled by me like 3 days ago using real-time CSG. So through a very simple process, just like what I've shown you before, just tracing the boundary of the existing building footprints and extrude them. And if necessary, you can use the subtraction process as well to create the internal pathway and even some of the, well, if you want to create some cul-de-sac, that will be also available using real-time CSG. And the second process is that you can reposition and relocating the spawning point at the corner of your in the Unity interface. Right here, I'm just putting those spawning points at the anchor store of each block, and you're not necessary to focus on the Barcelona urban the super block only. You can model something that you are familiar with. Say, for instance, if you are familiar with Chinese cities, then you can definitely model something from scratch by yourself in the next couple of hours. Or if you are familiar with the Melbourne urban context, you can model something in I don't know, Footscray, or you can model something in the CBD area. And if you're coming from India, then you might want to test specific urban fabric in Mumbai or New Delhi using the real-time CSG plugin and the ABM system that we've provided. And I think you can, if you can now jump back to your Unity's 3D interface, you can click on the play button. and see how it works. Okay, right now I think I'll switch back the I'm using the speed mode, which is pretty straightforward, as what Jeff have already introduced to you guys. And you can also switch between different kind of modes, like the directness and also the proximity mode, to testing how different urban typologies would impact on the pedestrian behavior, and also how it would influence the crowd behavior under certain design proposal. So that's very much about the real-time CSG and the case study environment. I think in the next couple of hours, you guys will be able to model something by yourself in the Unity interface and test out how the agents will move using the ABM system. So are we going to split them into groups as well, Jeff?
Yes, I believe that would be good. There are 9 people, so
okay,
three sort of promotes discussion.
Not stop sharing the screen.
Yeah, okay. Look, if I can just quickly, am I muted? No, I'm not.
No.
I do have the agent working. If I can just quickly demonstrate that, please. Oh, what am I doing? Okay, you should now be able to see my Unity interface. The problem was quite simple. I just hadn't set up a few things. I'll paste some instructions in the chat as well. So if you go to the project and assets, agent system, models, avatar, you'll see this AI PED. This is the little animated person. Up on the right, it just needs to have the layer set to agent. And say, yes, change children. The other thing is whichever agent system you're using, and remember that in different folders, there are different agent systems because you're turning them on and off. So if we go to the agent system I was using in the intro environment, go to agents, agent controller script. Down here, these 2 things weren't set. So for the sun needs to be dragged in. And for the mask, it just needs to be set to default. Look, default. And once it says default, then that's fine. Okay, now if I now go to the agent controller, it's set in solo mode, and we'll be able to see what is happening. Here come our little people. They hit shade. You can see that they're starting to experience shadow. And you can also see up on the building the points of solar obstruction. As I said, you can change the delta sun and delta shade. So I could make it longer for them to warm up, which means that they're now staying bluer after they've experienced the shadow. That was the entirety of the solar mode I wanted to show you. I'll send the instructions for making those changes in the chat very soon. The other thing I wanted to show you just while we have a Unity interface open is Shaoran was talking about how you can start designing your own explorations. And what can we'd like you to do to keep a record of the iterations you're making is to actually make copies of the work you're doing and then provide us with your project at the end. So Shaoran was showing you this Barcelona superblock. If that was what you were using, you could then, once you've done some experimentation and made some modifications to it, you can then just right click, say duplicate, and start using the new one after turning off the old one. And that way you'll have a record of the changes you're making. Okay, that was all for using this, and I'll pass it back.
This one thing I forgot to mention is the how to change the workable cost in NavMesh system. So probably I'm going to share my screen again. Yeah, there's one thing I forgot to mention is the how to reset the net mesh cost to different kind of surface. Say, for instance, in the Barcelona superblock case studies, I have differentiated the the artery road and also the sidewalk for pedestrians. So apparently, we would like the pedestrians to follow the sidewalk as much as possible, but also giving the chance for them to cross the road if necessary. So in this case, what we need to do is to identify the different costs between different surfaces in Unity system. So here, what we need to do is to click on those. Click on the surface that you would like to change the walking cost, and click on the navigation to be able to find different layers and different cost for the nav mesh. So we have a very walkable surface, which cost is 1, and not walkable, which are places that agents would never go. And just ignore this layer, jump, we're not going to use that one. And we can also create other layers based on our preference. So here we're using a layer called not so walkable and increase the cost to 5. So what we need to do is to click on the artery road plan and switch back to the object. And if you hover your mouse down to the navigation area and click on that one, and then you will have 4 different options, which refers to the area that we have in here. Okay, so what we need to do is to select on not so walkable and click on bake, and you will, and you will be able to generate a nav mesh surface that have different costs, where the blue area represents walkable area for pedestrians, which are the sidewalk, and the which is for vehicle, but also in, well, let's say in some circumstances, agents would also able to pass through it. So if we run the simulation, you can see the agents tends to follow the sidewalk, but if there's a shortcut or if the agent's trying to cross the road, they can still do so. So you can make the scenario more similar to the real world. And yep, that's it. Jeff, you're muted.
Yes, right. Thanks, Xiaoran. Okay, look, the next step was we just wanted to explain the overview of the remaining time in the workshop. And then we wanted to split people up into small groups just to promote discussion more easily. With 9 people, it would start getting a bit crowded with everyone trying to talk. Okay, Sharon, I'll share the okay, you've got a copy of the timetable in the MS Teams. So the next step, starting at 1 o'clock, is a break time when you'll be able to grab some lunch, and we'd like to keep that as also an informal group discussion for you all once you're into your groups. And that would be the stage also when you would start modeling your initial urban environment that you want to test. So just to emphasize, that initial urban environment doesn't need to be optimized. The point of the work in the afternoon is to start to make changes to it based on the evidence you're getting from the agent system. You don't need to worry about making it too detailed. and just model it to the extent you're comfortable with. Now, we've also provided the Barcelona Superblock scenario that Xiaoran has created. So if you don't feel that you produce something that you want to work with in the afternoon, that's a fallback for you. At the end of the lunch break, we'd like you all to have discussed with each other in your groups some of your initial ideas about what you'd like to achieve and what you want to test, and to have each of you your own model to start iterating with for the working session in the afternoon. On MS Teams, we've provided some extra channels for groups, and in that is a template PowerPoint. You should be able to access that template directly through MS Teams and make some changes and paste in a few comments. So in the afternoon, we'd like you to then iterate through, in discussion with us who will be joining your groups, various scenarios on your urban environment. And as you do that, could you please, in the PowerPoint provided in your channel, just make a few notes about the steps you're getting to as a team and to coordinate as a team together. Could you also, within your individual projects, as you're doing iterative steps, duplicate the work as I showed, so there's a bit of a record? And we'd like you to please upload your project at the end to the MS Teams. And in the cheat sheet we provided on Sunday, there's a section at the end that explains how to upload a project and to reduce the file size. Okay, following the afternoon session, which is 2 p.m. to 4 p.m, we will have a discussion and wrap-up session where we'll all get back together and talk about some of what we've done. And we would like one person from each group to be the primary person to just present some of the explorations you've taken and what you've discovered. And then we will be concluding around 5 o'clock. Xiaoran, did you have anything to add to that?
Not so much, because okay. I was expecting them to forge groups before the workshop, but apparently we have 9 candidates here, and it would be easier for us to split groups right now into three groups of 3. Do you guys think that works for you, or you prefer other options?
Yeah, certainly if someone has a strong objection. Our reason for it is we just thought it would help people discuss more intimately, as a group of 3 rather than in a whole room of 9. But, we want to do what you feel comfortable with and what works for you. If there's no objections, we'll just divide people up into groups of 3. Okay, well, I'm seeing some nods and no shakes, so we'll go ahead and do that. Xiaoran, should we just go through in order? Left to right, top to bottom?
Yeah, sure thing. What I need to do is to create 3 breakout rooms for you guys, and oops. Oh, it actually automatically generates 3.
Oh, does it?
Rooms. Yeah.
Okay.
And it automatically distributes peoples into that.
Oh, that's fine then. Yeah.
Yeah, but wait a sec. We need to excluding us as well. So we need to exchange with. Sorry. So I'm going to open all rooms for you guys. So you'll be able to have chance to have some intimate discussions with each other, and also, getting to know each other and starting the discussion about the new urban design proposal using ABM. So there we go. Do you all receive a popping up with a breakout room notification? And if you click on that one, you'll be able to join into that one. Jeff, you suppose you can move to breakout room 1, and you can also stay in this room as well, and we can then jump into each room and make sure that
Right.
They're working well. Zelda, are you there, Zelda? Oh, sorry, I was sharing screen with another candidate, so I couldn't see you pop up. So now you'll be able to join the breakout room. So if you move your mouse to the bottom and click on the breakout room, and then you'll be able to join back to room 2. Can you do that? Hello? Are you able to jump back to the breakout room right now? Yeah, you can just hover your mouse to the bottom of the Zoom and click on the breakout room icon. Yeah, and then you'll be able to join back to the breakout room. Hello, Jeff. Are you there? Hello, Jeff. Can you hear me? Yeah, I'm there. Hi, Jeff.
Hi,
Can you
sorry.
hear me? Hi.
Yeah,
Hey, hi.
yeah, this is being streamed, so it's not a private conversation.
Oh, yeah, I know.
Yeah.
So, yeah. Same error now.
So I think group 1 and group 3 should be fixed now.
Mm-hmm.
Would it
So I
be
think the group 2 having the same problem. So we might. I've already asked them to delete the library and reinstall the real-time CSG from the SS store as well.
yeah.
But it takes some time. So maybe
Yeah.
we can jump back to the breakout room 2 in about 5 minutes or so.
To which group did you say?
Group 2.
Sure, I haven't been to group 2 yet. I've only been to group 1 and 3, so I'd be happy to go there.
Okay, cool.
Unfortunately, I can't assign myself to a room. I've got to rely on you to do it.
Well, that's sweet. Even though I've assigned you as co-host, you can't assign you into one of the rooms.
Well, how should I be doing it?
Can you click on breakout rooms?
Yes, all I get is a message saying I'm assigned to breakout room 3.
Okay, so it seems that only host can do it. Do you want to be the host? I can hand over to you. So
no, look, it makes no difference, Shaoran. Yeah. You know how it works anyway, so it's better you stay host, and one of us is going to be inconvenienced. So let's
jump into room 2.
Yep. Okay. So let's meet.
So I'm gonna assign you first.
Sure. Okay, I'll go there.
Okay, go there. It's okay. I mean, I know it's a little bit late, but the thing is that I've already split all the candidates into 3 groups already. So we have a breakout room 1, 2, 3. So if you guys don't mind, I could probably assign one of you into group 2 and another one into group 3, I reckon. Because it's
hello.
already super late. Like
yes,
3 hours have passed.
Yeah, hello. Well, when maybe I will, it would be a little awkward to intervene with the dynamics of the particular group, but I don't know. Depends on you.
Yeah, but the thing is that I can't create new breakout room for you guys once it's started. And I think the Cadrea organizer is streaming the main session. So if you guys don't mind, you can stay in the main session and you two can fetch a new group if you want. If not, then I'll try to assign one of you into group 2 and another one into group 3.
How long is the group session?
It's gonna last for another 1 hour and a half, I guess. It's almost finished. We're going to close the session by, oh, okay. So in Melbourne time, there's gonna be 5 p.m. So only like 2 hours and 20 minutes to go. So you can join in one of the team and start to do some interactive design using ABM. Because it's apparently too late to starting something from scratch.
Yeah, well, I think it's better now just to probably just to participate watching. I don't know.
Yeah. How about you, Xinwei?
I'm fine. I think I can be assigned to another group because I don't know what to do if way to from a group.
Yeah, okay then. So, Manuel, if you don't mind, I'm gonna send you into group 2. Okay. So there we go. We have another studio leader, Jeff, here. So hopefully he can help you to sort something out. And Xinwei, yeah,
yes,
I'm gonna jump into group room 2 later as well. So you'll be able to see, yeah, something pop up on your window and just join in.
Yes, I have the pop-up window. Thank you very much. Sorry for the inconvenience.
Yeah, no worries. And the Xinwei, I'm gonna assign you to room 3 then. Is that okay?
Yes.
Hi Jeff, I'm back to the main session. Yeah, I've already assigned those two candidates to group 2 and group 3 respectively. So
I was in group 2.
So you see you saw Manuel already, and
yes.
Okay, I was in group 3, so it seems they are working pretty well at the moment, and they are planning to model something slightly different to the Barcelona superblock. They might going to model a linear area in Shanghai,
sure.
which I think is quite challenging given the time they have right now, but we'll see.
Now, Xiaohan was saying that she wants to use a Rhino model she has of a site she's worked on. And what's her name? I've got a mental block.
It was intensive, isn't it?
Yeah. Zelda. Zelda was seemed very happy to work with that, so I said they should just go ahead and use it and do some exploration using it.
Okay, sure.
So look, I'm presuming that was, I presumed at the time that would be fine with you. I thought, given time constraints, and they wanted to do it, it's better just to go with it.
Yeah, I mean, it seems that we only have like 2 hours left, so maybe we give them like 1 hour and a half to run several iterations.
Yeah, and she showed me the Rhino model, and you know, it was fairly detailed. Anyway, that's what I thought was better to do. Have you looked at Group 1 recently? Hello? I've lost your audio.
Oh, sorry. My AirPods were running out of battery, so I have to switch it back to the the desk.
Sure, fine. I was asking about Group 1. I haven't looked there yet since the very beginning of the break.
Yeah. So maybe after like 10 minutes, we can jump back to the Group 1 and make sure they're on the right track.
Okay. Well, I've been in Groups 1 and 3, Groups 2 and 3 recently. So going to Group 1 would be good after 10 minutes or something. I think there are two things we've got to make sure that people are doing is that they're actually doing some testing and iteration.
Yeah,
and that
also making archives for that.
They're making the archives so they can upload the project. Now, I showed to Xiaohan and Zelda the wiki, not the wiki, the PowerPoints on MS Teams. Is everyone able to access those?
Yeah, I think so.
Yeah, everyone can start a new post. Yes. Okay, so they should all be able to access them. They can just find their appropriate channel and use them if they wish.
Yeah, I've already uploaded the template PowerPoint file for each group, and they will be able to find, the slides readily available in the file folder already, so they can just simply drag and drop some of the screenshots or animations they recorded.
It looks like no one's actually started doing that, and I suspect, given the time, they might not actually get much done in that respect. As long as if they don't, as long as we capture the Unity projects themselves, that would be good. And maybe they'd be able to speak to the Unity project while screen sharing it. And they could show their iterations, for example.
Yeah, I think we should re-emphasize that to each group. I'm happy to jump into other group and just to make sure that they are going to upload some screenshots and animated, recorded animations to the slides. It's already there. What they need to do is just to drag and drop. So it shouldn't be too complicated for them.
Sure. Okay, fine. Xiaohan did ask about when we wanted submission. And she was asking about like tonight or tomorrow. I did say that, at the end of the class would be, is when we're expecting it. It might be worth saying to her later that, certainly if she wants to advance something, we'd be happy to work with her.
Yeah, that's true. I mean, we should probably guarantee that they will upload something by the end of the day for each group, that they at least a project. But if they want to further, extend, the usage of the ABM system, and I'm more than happy to, get another revised version by tonight or tomorrow. So yeah,
sure, okay.
Yeah, thank you, Jeff. That was a little bit chaotic.
yeah. It all seems to be working out now.
But that's super weird because I've shared that file with you before, and it was working really well. And the problem seems didn't happen for group 1, and it's only
well, group 1 was having trouble with a couple of files, which I put back in. But the original Google Drive archive was working fine. But, it's possible someone deleted a couple of files.
Yeah.
Once it was uploaded. There's no way of seeing the history.
Yeah, because, I think that's for group 3, only misses 2 files, which are the sun position and the helper. Well, for the group 2, when they download the file, every single file within the that folder was missing. So it's super weird.
That's bizarre. I think next time we should just upload a zip file.
Yeah.
And that way the zip file's either there or it isn't. And no one can really delete things. Anyway, look, we've resolved it now. I don't mind going a bit overtime if necessary, Xiaoran.
Yeah, I don't mind either. So if we can, say, extend like half an hour or so, I'm okay with that.
Yeah. So, if we do, as you say, and give them an hour and a half from now for modeling, and testing and iteration, and then we can bring everyone back.
Yeah, sure. So yeah, maybe we can come back to the main session in 2 minutes. We can go to the bathroom and grab some snacks, and then we can jump into group room 1.
Okay.
So shall we meet up in 1:15?
Yep, sure. Yep, 3:15.
Yep.
In my time.
Sorry. Oh yeah.
No,
so 1:15 for me.
Yes. Yep. I'll be back here then.
Okay. Cool. Yeah.
Okay. Right.
See you shortly.
Okay. Right. Bye.
Yeah. Bye. So Jeff, shall we jump back to group 1 and see how they're going?
Yep, that sounds good. Okay. I'm still in breakout room 2. You'll need to reassign me.
Oh, jeez. I was forced to switch back to the airport mode, so I didn't hear you. Sorry.
All right. Okay. I said I'm still in group 2. Could you please reassign me to?
I'm assigning you back to room 1.
Yep. Thank you. Okay. We're going in now.
Yeah. I'm jumping in right now.
Okay. See you there.
Yeah. See ya.
Bye.
Hi, Jeff. Oh, you're muted.
Hi.
Sorry, for the group 3, I thought it might be easier for me to just,
Yeah, no, look, I agree.
in a very quick manner, because they have raised up so many questions. And,
Mandarin.
Yeah, just faster. Sorry for that.
No, that's fine. It didn't worry me at all. I was being quite sincere when I was saying, should I just leave and let you talk in Mandarin?
Okay.
Okay. So they're going okay now, are they?
Yeah, I think so. They know what they're doing, and I've already explained them how to drag and drop screenshots and recorded animations to the template.
Yep.
So presumably they are starting to do some stuff on Steam ready. Not sure. I'll keep an eye on. Yeah, I think they're going on the right track.
Okay.
Group 1 should be fine. Group 2, Group 3. Yep.
Yeah. Okay. So did you want to go back to a group or leave it for a while?
Yeah, we can say leave for like 10, 15 minutes or so and see if they have any questions, and then we can.
Okay. Well, I'm quite aware it's now 4:10. So we can probably only leave everyone for another half hour, or most 40 minutes before we've got to get to the conclusion bit.
Yeah.
And that's
I mean, for the discussion, we don't really need to leave very much time for that. Say we can save like 20 minutes or so.
Yeah.
And give like 5 minutes for each group for them to demonstrate what they have done in the past couple of hours, and leave 5 minutes for us to, well, say the conclusion to the candidates, to have some concluding notes. So presumably we can end before 5:30, I think. So what would you reckon? I'm okay if we stress this to 5:30.
Oh yes,
But
look, I
if you
am
wish
too.
to.
It's just whether participants want to stay on for longer. You know, that's their choice. I noticed no one seems to have touched the templates yet, but we can't do much about that. They either do or they don't.
No.
Should we make in the general channel an upload for the files?
Yeah.
To upload the files?
Yes.
Okay, so I'll just make a folder called Please Upload here.
And maybe add all the Kadria workshop candidates. Well, maybe post an announcement to re-emphasize that everyone is supposed to upload their project by the end of the day.
Yeah. Okay. So we've got Gu as a candidate.
Gu. Yeah. Gu Zhuoxing.
Yep. Well, I'm just using first names. So I don't need to check the spelling as much. Rob. Victor. Bin. And Wei. And Xiaoting.
Wei.
Okay.
I think I can create a folder because I can see all the names from the breakout room. So.
And well, could you have a look? Can you see that folder now in MS Teams?
Yeah. I'm checking it. Xiaohan
Okay.
Sauda.
Just check the
Ripple
spelling,
shouting
please.
waving it's Rob too. Yeah. Should we also include Manuel as well?
I've added him now.
Okay. Yeah. But, shouting, get away. Yeah. That's it. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
And perhaps after the workshop, we could join a separate Zoom to talk for 5-10 minutes, debrief in private.
I know. It seems well, we are the only one-day workshop, right?
There was another one-day workshop.
Really?
On AI, I think.
Okay.
Yeah.
Who shouting? Are we missing anyone? We're supposed to have 11 candidates.
We're supposed to have 15.
Xin Wei.
Weren't we?
Yeah, that's a new one. I can add his name, her name. She's in group 3.
Oh, right, okay.
She was late for the morning session. So.
Fine.
Okay, so now we just leave like another 20 or 30 minutes to them, or is that enough, or maybe 40 minutes for them, and then we can come back to each breakout room.
Yeah. They're able to contact you, aren't they? By sending messages.
Yeah, I'll stay there.
Yeah. Well.
Yeah, but with the camera turned off.
Sorry, you were saying group 3.
Yeah, I'll stay here in the main session, and if they have any burning questions, they can just message me, or they're able to message me. And I think there's one button called in the breakout room that allows you to raise hand or something like that, so I can see whether they need help and we can jump in.
Mm-hmm. Fine. Well, okay. Yeah, there was one-day workshop running today as well. Another one.
Okay. It's about AI.
Generative design / optimization.
Oh, I see. So we can just stay in the main session, and meanwhile, if they have any questions, and we can just
we can just go to a room if there's any help needed. I think at this, jumping in and seeing if they need help can often just disrupt them when they're getting on with things.
Yeah, that's true.
Yeah.
So if everything going right, then maybe there's no question. We'll meet again around, in Melbourne times, that will be 4:40, let's say, or 4:45.
Yeah, 4:40 is 23 minutes.
So that's not enough. Then 4:50 then.
Okay, fine.
Yeah.
That's 33 minutes. Okay, well, look, I'll just stay here and I'll be monitoring my email and the chat.
Yeah, I'll be there as well. Just keep an eye on those breakout room.
Fine. Okay, well, I'll turn off video and so on.
Yeah, me too.
Okay.
Hello. Hello, Miss Dane. Are you there? Hello, Miss Dane. Can you hear me?
Hello?
I said hello, but it seems nobody. Or she's not there? Or
Hello?
hello? It seems she's not there. Maybe I just type it to Miss Dane then. I've sent a message to Miss Dane already. You can hear me, right, Jeff? Weird. But you're not unmuted. You are. I can hear you typing.
Oh, right.
Oh, now you can hear me.
Yes, sorry, I had my speaker on mute without realizing.
Okay.
Right, okay.
Yeah, because I could keep hearing you typing, and yeah, it's weird that you can't hear my voice.
Yes.
Yeah.
Okay. So I'm not sure who has joined us here.
I think that's Miss Thing.
Right. It seems to be a different name. But, I did send a message to that person asking them to unmute so we could talk with them. But anyway, it seems like that's not happening. I just wrote in the chat to you. Should you send a message? Yeah.
Yeah. Sure.
Because we probably should be bringing them back very soon. And then ask them to summarize, and we can close it off and ask them to upload their projects as well.
So shall we ask them to come back to the main session in, let's say, 20 minutes?
Okay, well, you'd need to tell them we're actually extending the session then.
Yeah.
And ask them if they do need to leave before then, could they please make sure they upload their project to the folders we've created? Or we can send a follow-up email later.
Yeah, then, well, I can't really type that much. I think there's a words limitation for broadcast, like
do whatever you think
20
is
words or
suitable.
something.
Do whatever you think is suitable, Sharon.
Yeah, I just.
We can send a follow-up email later, you know, if anyone leaves and doesn't add a project.
Or do you think it would be appropriate if we just jump back to each room and right now and check?
Okay, let's do that then, starting
Yeah,
from...
I think that would be more straightforward. Yep. And
1 to 3?
They are, yeah.
Okay.
So let's jump to group 1 first and quickly, like say, take like 30 seconds.
Yeah, just telling them what we just spoke about. Fine.
Yeah, that's it.
Okay.
Yep.
You're muted, Sharon.
Sorry. Did you receive the email from Miss Ding?
Yes, I did. I
yeah,
saw
she
that.
has extended 2 hours for the session.
Yeah.
Currently, we don't really need that much time, but
I don't know if we'd be able to encourage the participants to take that much extra time. I sent a thank you note back to her.
Yeah, that's good. Okay. Shall I send a broadcast message to all of the candidates?
Say 3 minutes, we'll bring them back.
Yeah, 3 minutes.
Thank you.
So you have already sent the thanks email to Ms. Ding already?
Yes, I have.
Oh, okay.
USCC.
Oh, okay. Oops. Oh, we're still being recorded, so. Thought they would have done some practice before this workshop.
Well, it would have been useful if they had actually downloaded the project as requested and
at least play around with the Unity interface.
Yes.
It's a bit shame. I'll click on the close all rooms button so everyone will be forced to go back to the main session in 1 minute.
Okay.
Okay, so our breakout room will close in 54 seconds. There we go. I can see Team 1 has uploaded some images
Yes. Cool.
to their PowerPoint, so okay, not too bad.
Okay, everyone's here. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, okay.
It's 11.
Okay, Sharon, or shall I?
Yeah,
okay,
I can keep going. This one.
Yep, great. Thank you everyone for coming back to the main room. What we'd like to do now is just to have a quick overview of what all the teams did from one person in each team, just very briefly, and then leading into a sort of very brief sort of discussion of the outcomes of the workshop itself. We hope to keep this to within 20 minutes, so just sort of something very brief and casual. Perhaps Team 1 could go first and share their screen.
Okay, I can share my screen, and me and Ripple can explain the project.
Yeah.
Yes, please do so.
So, so first we are trying to divide our group to everyone and start to mod in a place to try to run the simulations, but we struggle a little bit on the how to pass all the information to these new models. Then we decided to run the simulation on the Barcelona model, and let me just see. I think that I just sharing the it's that one. So we run the simulation on the Barcelona model, and we'll make a couple of videos, and
I mean, the idea was to observe through these agent paths that which are the congestion spots that we could think of. I mean, which we could visualize using these agent paths, and based on that visualization, we were aiming to provide some solutions by using the geometric operations of booleans, where we could deduct some mass of these blocks to provide more rooms for the better flow of pedestrians. So I mean, that was like the overall aim of doing these simulations and trying to extract few information from that. However, like due to maybe like the time constraint, we were not able to achieve everything from there, but obviously like we learned through this process that obviously these kind of visualizations could be made a bit more easier, and could help us very well in the kind of designing it with the people, or designing it as per the flow, or as per the occupancy of the city, or the on urban scale. So that's what the learning would be from this whole workshop for us.
yeah, yeah. we we had some intentions that we could not achieve in the final, because you just discussed about these techniques that you could use to use the simulation as the feedback to improve the design of this place. Yeah, but this is what we are trying to quickly model part of Adelaide as well here. But here I have a question as well, because I didn't know if the model is is running on based on the Barcelona model, because I just put the mesh constraints here, but and try to run the simulation, but we struggle a little bit on that. I just put here to show the process that you are trying to 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 run the simulation in another context as well. Yeah, maybe just they make some videos on that. Yeah. Yeah, you really out of the time, but yeah, we are trying to figure out how to make this simulation working properly. Yeah.
Yeah. Look, I think that's a very interesting outcome for the length of the workshop, and particularly that we had some sort of technical difficulties early in the afternoon. So what do you think would be the next step for developing the model?
The next step to develop this model, yeah, probably fix this uh, these technical issues, and then trying to analyze. I choose this specifically based on Adelaide because it's a place that they're trying to improve the laneways because it's a north-south connection in the city. It was just interesting if they could be an interest place for the connection because they have these small laneways that they can want to improve the activity. And so the next step should be first try to model this more precisely.
Yep.
Because we try to modeling this very quickly. To have the outcome more precisely as well. And then we could try to use that information, that simulation, compare with other studies, for example, to see the accuracy of the activity of these streets is matching with the past studies.
Yep.
Yeah, all trying to correlate that with some walk score or something like that. It's just something that I was in mind, trying to correlate that with other measurements and see and look at the model, trying to understand.
I think using this simulation or maybe the data feedback of, say, the way agents move in a space, I think it could very well be used for designing like maybe extrusion heights of the blocks, even the paths and the footpath, so that that's kind of optimized in a way if you are kind of building a new like location or kind of working on a site. Then I think these things could be very well optimized to the process of this kind of flow. I think it could be useful in that line as well.
Yeah. The connection that I'm referring to is that connection south from the Adelaide Oval to the market here. They try to make this, and you just choose these blocks here. So it's very important.
I think on an urban scale, I feel we can also, like, these simulations could also be useful to understand like there might be some spots in the city. For example, if we go on Oxford Street on London, there might be a lot of artists playing, they're like doing various kind of stuff, and there might be a lot of gathering at that location. So like, how do we simulate such kind of processes? Even that could be an interesting fact because there might be these kind of some attractor points which eventually kind of attract some public, and there is a flow which goes on as well. So, you know, these kind of simulation could make like the visualization a bit more interesting, and it would eventually like put more character in the location, in the context that we are kind of choosing. So I think this could be taken to a extent. I mean, this could be extended further in this way, I feel.
Yeah, that's an outstanding point.
Yeah, very good.
Yeah.
So I just stop sharing.
Yep. Okay. Sharan, should we move on to the next group in the interest?
Yeah, sure. Yeah, so kind of running out of time.
Yeah, but that was really fantastic. Thank you.
Yeah, especially given the time constraint, that's a really good result, I would say.
Yeah. So group two.
Group two.
Sharon, you share the screen?
Yeah. Yes.
You can.
Yes.
You start?
Yeah. Here is our group members: Libin, Xiaohan, Zelda, and Manuel. And this is precedent studies that Libin maybe.
This is the previous studies about the urban design, about the pedestrian distance and density of managed by pedestrians. So in fact, it's a little bit different with the Unity. The workflow first we should collecting the data and mapping on the site, then analyzing the data. But we can also to analyze the pedestrian densities, something like that. Please, next page. And as you can see, when we got the data, we can mapping this data on the map to get the layouts of the function of the city. So click next page. And the set work of the density is also can do like that. It's a previous simulation about the. We think it's similar like this. So next, maybe Shahan.
Yeah. We choose a site in London beside the Thames River, and this is our residential place with river and garden around here. And so we also did some basic data analysis. First is the visibility and also road accessibility, food accessibility, and also people density using the Twitter data. So we can say this place is a people gathering place. So we when we simulate the pedestrian network, we also based on the people density with the Twitter data. So here is how we divide the walkable and also walkable place and the building. And here's a basic simulation, but it's just 0.33 3 agents spawner to see what will be like. And sorry, this video is not working. And then we based on.
Yes. Oh, you have a video?
Okay. Yeah, there's a videos. I haven't put it. So, this is based on the pedestrian, the people density. So here is, so sorry, it's just. So a lot of people starting with this place and this place. So that's how it will look like. And this is based on the distance in agent parameter. It will show the pedestrian network like this. And you said we can see and combine because this part is the park as we previous map, and we also can see that the park is really, I mean, it's a workable place for the people from there and here. So after that, yeah, this is finished. So that's it. Thank you.
Thank you, Xiaohan.
Thank you.
And thanks you for the efforts for the whole Team 2 members. I think that's an amazing outcome from a 2-hour studio time. And I just want to ask one thing. The final scenario in your simulation, you have positioned the spawning point based on population density. Is that correct?
Yeah.
Is that population density, and you summarize, or you found that data from ArcGIS or Twitter?
Yeah.
Ah, okay.
This is my previous work, so it's not, but it's still using Grasshopper to catch Twitter.
Yeah. I was curious how come you could gathering all this data and do the analysis within such a short time period. But I think it is a very good implementation of using agent-based modeling with the integration with other techniques like the big data analysis, etc. So see, you have summarized, you have investigated the population density based on the Twitter's data, and you've got the diagram and you've got the data set, and you take that data set as another input into another iteration, which is in this case is the agent-based modeling, and you set the spawning point accordingly, and then you can have this kind of evidence-based design iteration, which is very commendable, I think.
Thank you.
So absolutely amazing. Do you want to add anything, Jeff?
No, I think you summarized that very well, Sharon.
So shall we jump to the last group?
Yeah, okay. Yeah. Shall I share my screen?
Sure thing.
Yeah. Okay. Well, hello everyone. Today our group is going to okay, well, first here is our 4 group members, and our group is trying to finding out how the agents their activity on these surfaces. So at first it's from let me see. First the plan is about one of our group mates. Would you like to explain that?
Yes, I made a mate space and using the random positions of the generator to draw the route of the workers, and my initial purpose is to I want to draw this place. There is a figure and ground differences. So I want to draw some empty space shape to show the ground space, and if I adjust the figure, the shapes of figure, and I can get different ground spaces. So my program is I want to test the relationship between figure and the ground.
Okay, well, thank you for your explanation. The next one is from Mai, and first you can see the process of how I move these blocks, because at first I think that how will affect the agencies on these surfaces if I make like something bridges like the blocks and on the upside. But finally, I realized that there's no any effect if only if you put all these blocks on these surfaces. It can change their moving and change their activities. So the final blocks layout and how their activities is shows from these big pictures. And I also have a small animations here. I will show this one. Yeah, actually from these animations, what I found is there's a lot of angles of the blocks. I trying to rotate the blocks, put it on my surfaces, trying to see how they're when they trying to choose the different rows, how the angles will be. And it is obvious that a lot of rows is not very shows the right color. It's not very easy to go through it. Okay, well, next one I'll just passing my authority for the presentation to the Mr. Gu. Would you like to explain your
subject? Yes, I will do a short explain about this. It's my first time to utilize the Unity system to do this. I always do this in the Grasshopper platform. That is very useful for me to shape the shape of the geography and the texture. But I try. So this time I try to utilize this pedestrian to work out how the block morphology will influence the pedestrian behavior. And so this is basic typology. I choose 3 types of it, and the closed, you can get through from the blocks, or you can spread from the blocks. So next page, please. Yeah, so that the example, the outcome you can we can work out here, and not so familiar with this system, so it's not quite clear to accumulate the persons that are according to the change of the blocks. But if in the future I want to learn more about it and how to display when we change the shape of the blocks, and how to influence the numbers of pedestrians in each street, so that we can know how our design will influence. And the next page, please. Sorry. Can you next page? Yeah. And we can see when our design changed to more small scales and more choice to all the agents, maybe some problem will be solved. and that's my this work now. Thank you.
Okay. Well, this is the last page of our group presentation. Thank you for listening.
Okay, look, that was, I think, a very interesting exploration, and it was good to see you actually tried sort of, quite unique approaches within your group. And, I think you did do some real exploration of different morphologies of streets and buildings, and how, that actually is affecting the way agents are moving, and you've sort of uncovered some ideas for how it could be further developed. So, I think it's a very good outcome for the time we've had available. Sharan?
Yeah, I think I really appreciate the fact that they were trying to test the different parameters like the distance, and also they've done different kind of block morphology tests as well. And I think in that simulation, you were trying to investigate the permeability, how permeability could potentially influence pedestrian behavior, and how does the internal open space would positively impact on the pedestrian behavior as well. So I think that's a very good direction for future, for further development, let's say. And also I've realized that was Gu, I can't remember, yeah, should be Gu Guoxin. You have done a brilliant job by using a variable control methodology where you keep the morphology at the same, but you rotate them into different angles. That actually tells some story when you're doing very rigorous scientific research. So yeah, I think you guys have done a great job within a limited time frame. So congratulations.
Thank you.
Thank you.
Okay. So that essentially concludes our workshop, doesn't it, Sharan? Just maybe just a couple of housekeeping things first. We'd be extremely grateful if you could upload your Unity projects and your and also any presentations or screenshots or videos. I'll just quickly share. Okay, you should be able to see my NS Teams. So in the general channel in the file area, we've also created a folder, please upload outcomes here. And we've provided a folder for every participant in the workshop. So yeah, as I've said, we'd be extremely grateful if you could upload your work into those folders. Thank you.
Thank you.
And also, if any of you want to continue working on any of these things or want to talk to us about some of the stuff we've done today, you're always more than welcome to contact us, and you have our email addresses. So, please feel free to do so. Sharan?
Yeah, it seems that you have covered most of the stuff, and what I'm really want to say to you guys is that thank you so much for attending our workshop, and many thanks for your fully commitment and engagement to this workshop. And I just want to express my sincere thankness and what you have done in the past couple of hours is actually it's kind of amazing, and I didn't expect that you guys can do the work within like 2 or 3 hours like that. So yeah, thank you so much, and congratulations. And same as for Jeff, if you guys have any questions regarding agent-based modeling or the specific technical questions regarding the Unity 3D, so please feel free to contact us, and we're more than happy to answer the questions regarding to this.
Right. Well,
thank you for everything.
Everyone. We're going very
Thanks so much. Thanks so much.
Thanks, guys.
Bye.
Thank you. Thank you. Thank you.
You guys. See you guys.
See you.
Yeah.
See you.
Oh, I think I can stop the recording right now.
Yeah, there's a little stop button.
Yeah. Cloud recording.